Welcome my viewers, welcome back to my channel again. So we are discussing about the continuity and differentiability. Okay, and we are doing the solution of from the question RS Agarwal math book. Okay, we have done question number up to question number 4. I will provide you the link of the answer sheet, the answer of my that video. I will definitely provide you. Now for today we have done question number up to question number 4. Now we should start from question number 5. Okay, EX9C of RS Agarwal. The function is defined as 2 minus x when x is greater or equal to 1 and x when 0 less or equal to x less or equal to 1. Okay, so we have to show that f is continuous but not differentiable. Fx is we have to show that fx is continuous but not differentiable. Okay, now to check the continuity, what we have to do, we are checking the continuity. So limit extends to differentiable at x equals to 1. Limit x tends to 1 minus fx. Okay, so limit x tends to 1 minus fx means limit x tends to 1 minus fx. Now 1 minus fx means we are getting x here for here. Now if we put the value, we are getting 1 as a result. Next, limit x tends to 1 plus fx, that is limit x tends to 1 plus 2 minus x. Okay, x tends to 1 plus 2 minus x, so we are putting the value 2 minus 1, that is answer is 1. So from here we can easily see that my left hand limit, that is now if we take f of 1, that is functional value at x equal to 1, it is come 2 minus 1, that is 1, and also f of 1 is equal to 1. In place of x we are putting 1. So here limit x tends to 1 minus fx is equal to limit x tends to 1 plus fx is equal to f of 1. All the values are equal, so we can say that function fx is continuous at x equals to 1. Next, move to the differentiability. So this is the continuity part. Next move to differentiability part. Now for differentiability at x equals to 1, so the right hand derivative r of f dash 1, that's equals to limit h tends to 1 f of 1 plus h minus f of 1 by h. Now limit h tends to 1 f of 1 plus h. Now here actually h tends to 1 minus, so my f of 1 plus h should be simple 1 plus h. We are taking this function, this as function. Now my f of 1 should be 1. We have to consider this function, that is hope you are not seeing that. We have to consider this function. For h tends to 1 minus. Okay, we are considering this function. So this we have got by h. So now if we calculate that, limit h tends to 1 should come, that is that the values will come 1. Next move to, so this is my right hand derivative. Next move to the left hand derivative. My right hand derivative. Let's move to left hand derivative, that is L of f dash 1, that's equal to limit h tends to, sorry guys, this I have computed. This we take the left hand derivative, L of f dash 1. Okay, this we have to take, and now we have to take the right hand derivative. Limit h tends to 1 plus f of 1 plus h minus f of 1 by h. Now for right hand left hand derivative, we are taking h is equal to for left hand derivative we are taking h is equal to minus 1, that is here we are taking that is equal to minus 1, this is equal to minus 1, that means here minus 1 comes, so the answer is minus 1. Next, the right hand derivative, limit x tends to 1 plus. Hope you are able to solve, able to understand this, how minus 1 is come. We are taking left hand derivative here. Now limit h tends to 1 plus f of x plus h, that is limit h tends to 1 plus f of x plus h. F of x plus h means 2 minus 1 plus h. Okay, minus f of 1. F of 1, my f of 1 should be 2 minus 1. Next by h. So if we calculate this value, limit h tends to 1 plus 2 minus 1 minus h minus 1 divided by h, and that's equals to 2 minus 1 minus 1 minus 1 by h. Sorry, here we have so we have to show the left hand derivative and right hand derivative. Okay, so let us take the right hand derivative first. This is r of f dash 1, so that's equal to limit h tends to 1 plus f of 1 plus h minus f of 1 by h. So that is my right hand derivative of that function, given function. So that means limit h tends to 1 f of 1 plus h. F of 1 plus h means, since h is 1 plus, so we are taking this value, that is 2 minus 1 plus h minus f of 1. F of 1 means 2 minus 1 by h. Okay, so limit h tends to 1, this is 2 minus 1 minus h minus 1 by h. Limit h tends to 1, 2 minus 2, that is 0, that is minus h by h, means limit h tends to 1 minus 1, that is minus 1, my right hand derivative comes. Next come to the left hand derivative of this function, that is L of f dash 1. Okay, f dash 1 means limit h tends to 1 minus f of 1 minus h, we have to take by minus h. So from here h tends to 1 minus f of 1 minus h, that is we are taking this function, the function is this, we have to take this function. Now we are put it up the value, f of h tends to 1 minus f of 1 minus h means 1 minus h minus 1 by minus h. Okay, now from here we are getting limit h tends to 1 minus h by minus h, that is 1. So my answer is 1. So here we can easily see that my right hand derivative is minus 1 and left hand derivative is plus 1. So here r of f dash 1 is not equal to L of f dash 1. Okay, so it is not differentiable at x equals to 1. It is not differentiable. So the given function fx is equal to 2x when x greater than or equal to 1 and x when 0 less or equal to x less or equal to 1 is continuous at x equal to 1 but not differentiable at x equal to 1. So next move to another problem. The problem is given here that so that fx is equal to box x is neither continuous nor derivable at x equal to 1. The function is fx is equal to box x. Okay, now so here fx is equal to box x. So we are taking limit, first left hand limit x tends to 1 minus box x. Okay, so if we take the limit x tends to 1 minus box x, so that means the box x means the value of the integer that doesn't the largest integer that doesn't exceeds x. So here if we put this value over here, so we can get the result as 0. Okay, so this is my left hand limit, and if we take the right hand limit, that is limit x tends to 1 plus box x, that should come 1. Okay, that should come 1. So here left hand limit x tends to 1 minus doesn't equal to right hand limit. Left hand limit doesn't equal to right hand limit. So it is, so the function is not continuous at x equals to 1. Next move to the differentiability test. R of f dash 1. For that limit we will take limit h tends to 1, limit h tends to 1 f of 1 plus h, f of 1 plus h minus f of 1 divided by h. Now this is limit h tends to 1 f of 1 plus h. Now that means box of 1 plus h plus f of 1 box 1 divided by h. So here if we take the value, that is the box of 1 plus h, is equal to box of 1 plus h coming as 1, and box of 1 is also 1, and here h is equal to 1. We are putting the limit 1, so we are getting 1. Now left hand limit L of f dash 1, that's equal to limit h tends to 1 f of 1 minus h minus f of 1 by minus h. So that's equal to limit h tends to 1 box of 1 minus h minus f of minus, this is box of 1 okay, divided by, sorry guys, box of 1 divided by minus h. Now box of 1 minus h, here 1 is my integer and h is subtracted from it. So box of 1 minus h should be here how much? 0 should come here, plus 1. Okay, and this is h, we put in the values, then minus 1 is come. So if you calculating that, minus 1. So here my right hand derivative r of f dash 1 not equal to L of f dash 1. So it is not differentiable. It is not differentiable at x equals to 1. Okay, so neither it is neither continuous, not differentiable at x equal to 1. Next, move to another question. Next, move to another question. The question is given here. Fx is equal to 1 minus x when x less than 1, or x square minus 1 when x greater or equal to 1. It is continuous but not differentiable at x equal to 1. We have to show that it is continuous but not differentiable at x equals to 1.